Hello, I'm Roman. Welcome back to a series of the videos of implementing the convolutional neural network from the scratch. And in the previous video, I finished with implementation of the convolution itself. But when I tried to run the training, the results were like really bad. I mean, I had the accuracy like 10%, which is, just you can achieve this accuracy by filling all of the outputs by the same number. And I definitely had some sort of the bug in the code, so I started to dive into. And in between videos, I actually spent some time diving into the code. I had to skip a few recordings for personal reasons, but I still spent a little bit of time investigating what went wrong. So right now, let's take a look actually on what we can do. So right now we have there is a describe model that is using the convolutional layer. So we have the input that declares the grayscale image of size 28 by 28, depth meaning the number of the channels that we have in the image. It's 1 because it's grayscale, and then they have the height and the width. I could take it differently, but here I just hard-coded. Then we create actually the convolutional layer, and we initialize it with the input image shape, and then what is this? Okay, and then we have the convolution depth, meaning that we'll have 2 filters, and we have the kernel size 3, so meaning that the kernel size will be 3 by 3. Then, so we add in using the sigmoid activation function. Then we have 2 internal dense layers, the one that takes the output from the convolution. Then there is a middle one. They both, this one uses sigmoid activation, this one uses relu. Maybe that's actually could be changed. But yeah, let's see. And then there is a last one that actually creates 10 output values, and using the softmax activation, we returning the probabilities of the specific category. And I want to remind that what we're doing is we have a set of the images, and we training the model based on the fashion in this data set that could predict the category of an input image, meaning the category of the clothes. Like for example, what we have for this one. So for example, we have the train. Okay, so for example, we have it's basically numbers here, but if we take a look at where this actually run model, this one, oh no, this one, where did this check? Yeah, so for example, we have the t-shirts, trousers, pullovers, dress code, etc., etc. And so this is what we're trying to achieve. And I've played around with the different optimizers. Previous version, in between, I used the stochastic gradient descent. Right now, I switched back to the Adam, the one basically the same that we have had before. For example, if we take a look here, that's basically the same. The only difference that I made to the previous architecture is instead of having just 3 layers, I added the convolution, which may be not the correct way in terms of the machine learning, but the idea is to actually being able to use the convolution, at least the convolution layer. And we're using the category cross entropy loss and categorical accuracy because we're trying to predict the category, and then we actually train. And I will show you in a bit why I have these things. But let's try. So we are running it, and it will take a couple of time. Right now I have just 1 epoch, well, meaning that actually 2. While it's training, I can actually show what are the changes. So there are some loaded models. Then again, for the convolution, I actually changed the way I create the randomized values for the kernels, and for the biases I just used norm flow at 64 right now. I checked it's the same as using the NumPy version, so I don't have to decrease the value of it. And also there is one particular problem that I had with can I do this? Oh, with the index. So if you can see, there is an I in here and there is a K, and K actually an iterator that goes over all of the input samples for the forward pass, because the way this kind of framework is implemented, that I'm passing multiple samples all at once, it was done while I've been implementing the neural networks from the scratch, because we can leverage using the matrix product for multiple samples all at once, all in just one single matrix multiplication, well, product operation. And here I had I, and here I K. I actually managed to find it once I started to write the test, because the problem that the loss didn't decrease. That's the first problem. The second problem that I actually just set the value in this line. The problem with this one, it just replaces, for example, if I have several convolutions, like for example, if I have the depth on the convolution like 2, it means that I need to have the biases and then on top of it add the operation of the first convolution and the second convolution. Right now it was just replacing it, so that was incorrect. Funny enough that I have problems only in the forward pass. I actually need to double check the backward pass. Maybe I have some problem there. Okay, and actually managed to find this. Now, once I had. Okay, let me finish. Once I had the problem with not changing the convolution or model training badly, so I started just writing the test. That's, like one of the best ways to test your hypothesis. And at first I changed tested the convolution init. So I had a couple of assumptions: what should be the output shape, what should be the kernel shape based on the inputs. And yeah, second one, I think I found one problem with this one, but the next one is I actually started to generate some values. Hard-coded values, because this one is actually, using randomization. So this is just actually, I think I'm stupid. I think I should be able to use some seed value for the randomization, so I can use the same generated numbers, right? Okay, but so I have some predefined things, and then I started to actually code the forward method, and this is how I find all of the problems with forward method, because there were actually some out of the bounds crashes, meaning that it didn't reproduce on the real data, I think because the number of the batch size was bigger than the length of the input sample. This is why it was fine, but it wasn't fine for this one. Also, I changed the model data provider. I added the stochastic gradient descent into this, so we can actually save it and load it into the JSON, back and forth. Not all of the optimizers are ready to be serialized. That's just because I implemented all stuff that I needed for the first version of the category implementation, and then I just go in one by one and see what else I need to do. Yeah, so this is what I'm playing. I will tell you a bit what's this problem. So this is basically the changes that I needed to do in order for stochastic gradient descent optimizer to be able to store it into the JSON. So just using the standard encoding/JSON marshalling, and yeah, that's it. So if we take a look at the model, after basically 2 epochs on the train data, we have the accuracy of 80%. I don't remember what was the accuracy of the first version, but that doesn't matter actually right now. But if you take a look, there is another evaluation, and this is this one, and you can see that the accuracy is super small. But if we go into the main, this one, you can see what I'm doing. I'm training the model, then I'm saving it into CNN, then I'm saving it, I'm loading it, same file, and evaluate once again using the same data. Like for example, here I have the validation data. So it used here, it used here. Why? Right? Load model evaluate. But for some reasons, it produces different results. Yeah, I don't need the... So for some reasons, this one is different, and this is what I'm going to debug right now. Because that's actually the only one thing that stands in between me, well, using this model like in some sort of web service, etc. I actually have the server that loads the model, and there is a handle /predict, and we pass in the PNG file, and using the model that we have here, we can actually do the prediction. But before we can do this, we need to fix the problem. So this is what I'm trying to do right now. Yeah, this will take a while because it will actually train the model once again. Then I want to check the loaded structure and train structure. Maybe there is some difference. I'm not sure why it has different results. It actually works slower with the debugger attached, which is expected. Yeah, maybe I actually need to... I can reduce the size, the size of the model, so just to double check it. Or there is one way, actually what I can do, I can... What I actually can do, I can save the model, load it, and save it once again, and find the differences. Let's actually try this one. Okay, it's finished. Let me check if... No, wait. Okay, so I have two versions. So what I can do actually is to make them pretty, to make the comparison easier. See. Right? Then the question how I can... what I can use to compare to... Can I use JQ? I have the JQ. Okay, so it filters, but... Okay, how I can compare to text files one by line by one. Okay, so I have theme. Do I have something like this? No. Okay, I have div. Wait. Okay, I have div. I have assets. Okay, do sh assets. This one. Okay, do. Okay, let's remove age. Okay. So they're identical. Weird. Okay, so they're identical, but for some reasons after loading the model, it's different. Okay, let's try to take a look why start the convolution. Okay. I mean, the accuracy, that's the same that I used before. The loss category of this the same, so I wouldn't think that's the... Oh, actually... Oh, wait, where there's a convolution, dense activation. Oh! So that's the problem. The problem that I changed... Wait. Run CNN. So the problem that the sigmoid activation is not started properly. Okay. What I actually have, I think I need to do is in the store, I need somehow to indicate that there is a type that is not, is not used. So I think right this, and here else panic. Okay, 50 for top, log fatal f fatal known type, and that should be this one, right? Okay, so right now it should fail. Let me check. And what I will have to do is to decode. Okay, so there is activation. I need to decode the sigmoids. Okay, where is this one? Wait, where? Okay, that's the load. Store. Sigmoid, right? Sigmoid. Else if right. But actually, do I need to do something? I mean, there is an output and input, and that's it. I mean, how the load looks like, for example, for something like activation. So it just creates it and that's it. Okay. Okay, exit status unknown type. Right. Okay, so I changed it. It means that once I run it right now, it should not fail. Oh, okay, I didn't do this. Okay. First. So that's basically the same. Instead, it's going to be the sigmoid activation, right? Sigmoid. What else I have here? I have the sigmoid, softmax, do I have the softmax here? So we should have basically 1, 2, 3, 4, 5, 6, 7, 8. 8 layers after we load them. So let's test once again. Here we can see there's evaluation. Sigmoid, sigmoid. Okay. I mean, that's it, right? Loss, well, interesting that the loss is a little bit lower after the serialization, but the accuracy is the same, which is, I mean, so we have the same accuracy. It means that I can run the training for much more epochs. I mean, in general, I mean, I've been tried before and 5 seems okay. But, well, the current implementation, as you can guess, it's far away from being efficient in terms of the performance. It's just, you know, one thread, all of the loops, and too many additional copies. Again, because this implementation is intended to be done in learning purposes and not to replace some pytorch. But what it means that I will train the model in between the videos, and in the next video we can actually try to use it and compare results with the previous one. So I'm curious if I manage to, I mean, there are a couple of things I want to try. The first one is I want to compare the results with the previous model that did not use the convolutional layer. The second one is I still want to implement the max boolean. I need to rewrite it and take a look. Third one is I want to try multiple convolution layers, as I've seen in one of the examples. So for example, we have the convolution with some depth, then I will have the max boolean, then I will have the convolution that can use the results from the max boolean. Actually, right now I can't do this because the first implementation that I started to do was very strict for input with one channel. Right now I can have as many channels as I want, and the code is actually flexible to do this. Then I want to try multiple convolutions and then, you know, compare the results. So I will have several models, and I'm curious if I manage to get the accuracy more than 90%. It will take some time to play with the architecture, and because basically I will do some random things back and forth. Okay. So yeah, I will commit all of this into the Git, so you already can take a look, and if you want you can play with this too, because it seems it's working, and at least the convolution layer itself. And by the way, after I finish this set of the videos, I want to create a video kind of highlighting all of the problems that I face while I've been trying to implement the convolutional neural networks really from the scratch, not in the Python, because in the Python just, you know, like convolutional layer, I mean the initialization part takes more lines than forward and backward path combined, I think. And I want to highlight, you know, several problems that I faced. But yeah, that's all for today. I wanted to make this short video as I had some pause in the posting, so I want to move forward. Yeah. Thank you for watching, and I see you in the next video. Bye bye.